Hi, my name is Shruti and I am from Indian Institute of Science, Bangalore, India. My research is on optimal resource allocation for non-orthogonal multiple access or NOMA aided wireless networks. Wireless networks are under immense pressure. With the rise of IoT, billions of devices need connectivity. At the same time, 6G must support diverse applications like high-speed video, mission-critical communications, and ultra-dense networks. But here is a challenge. Spectrum is limited and expensive. Traditional orthogonal access methods where users are separated by frequency or time waste resources. This motivates the need for new multiple access schemes. NOMA or non-orthogonal multiple access changes the game. Instead of separating users orthogonally, NOMA allows them to share the same frequency and time resources. How does it work? Users are separated in the power domain. This is called power domain NOMA, which is one of the forms of NOMA. At the receiver, a technique called successive interference cancellation or SIC is used to decode signals. This improves spectral efficiency, fairness, and connectivity, which are key requirements for 6G. Of course, the challenge is how do we allocate resources optimally in NOMA? There are many factors to consider. Frequency selective channels where subcarriers behave differently. Fairness, so weaker users are not disadvantaged. Discrete rate adaptation, which is used in the standard and is different from continuous rate adaptation that is assumed in theoretical works. Scheduling of users, saying that which users are to be selected for transmission. Power adaptation, which is crucial for power domain NOMA. And the fact that SIC is imperfect, meaning residual interference from the previous decoding stages must be accounted for. Finally, adaptive SIC decoding order where order of decoding is not fixed but can be optimized. This adds another layer of complexity. Our research developed systematic methods for resource allocation in NOMA under these challenges. First, we considered NOMA in frequency selective channels, accounting for common modulation and coding scheme power constraint which is imposed by the 5G standard. Here, the standard mandates that a user must use the same MCS and power across all subcarriers assigned to it even though they see different channel gains. Second, we design fairness-aware algorithms for multi-user NOMA when SIC is imperfect and decoding order can be adaptive. We also showed that adapting the decoding order improved the performance as the number of users increased. Third, we extended this to semi-grant-free NOMA, which balances reliability and efficiency by mixing grant-based and grant-free access. Here we did a fairness-aware grant-free user scheduling and discrete rate and power adaptation under common MCS power constraint in frequency selective channels. Our works have been published in IEEE journals and conferences. We also have a patent filed on enabling NOMA in wideband communication systems. To summarize, our work addresses the question that how to allocate resources optimally in NOMA systems. By tackling fairness, imperfect SIC and frequency selective channels, our research brings us closer to making NOMA a practical enabler for future wireless networks. Thank you.